To discover the prime composition hidden inside any composite value, mathematicians rely on two primary algorithms. First, we have the vertical division method, which acts as a progressive numerical breakdown. Second, we have the highly visual factor tree method, which creates a branching family of products. Let's break open the number 16 using both. Starting with the division method, our goal is to consistently strip the number using prime factors until only one remains. We take 16 and divide it by the smallest prime, 2, which cuts it to 8. We divide by 2 again to get 4, once more to get 2, and a final division leaves us with our target remainder 1. By gathering our divisors on the left, we reveal that 16 equals 2 times 2 times 2 times 2. Now let's look at the visual alternative, the tree method. We begin by establishing our base value 16 as the supreme parent node at the top. From here, we split it into its first pair of matching child products, 8 and 2, because 8 times 2 equals 16. Since 2 is prime, its branch locks immediately while our composite 8 keeps expanding. We repeat this branching process down the line. The node 8 breaks open into 4 and 2. Then the remaining parent node 4 splits into its final terminal pair, 2 and 2, because every single ending branch now finishes at a prime number. Our visualization tree is fully complete. By collecting all the final nodes that have no children, we discover the exact same atomic reality. 16 breaks down perfectly into 2 times 2 times 2 times 2.